reactions. So far we have seen the introduction part of exothermic and enthalpy reactions. We have also seen energy level diagrams for endothermic and exothermic reactions. So in this discussion, I want us to look at the calculation of enthalpy changes. That is the energy changes during chemical reactions. So for a chemical reaction to occur, bonds must be broken in the reactants, and bonds must be formed in the products. So when bond breaking, so during bond breaking, energy is absorbed or energy is taken in. So that is endothermic reaction. And when during bond formation, energy is released to the surroundings, so which is an exothermic reactions. So when now calculating the enthalpy changes, you add up the energy or the bond energy of the reactants, and you add up the bond energy for the product. And so the change of enthalpy will be now the energy taken in minus the energy released. So in our case, we have this equation, and we are given the bond energies for each bond. Here we have a carbon-hydrogen bond. The bond energy is 413. A carbon-carbon bond, the bond energy is 346. A chlorine-chlorine bond, the bond energy is 240. Carbon-chlorine bond, 327. And hydrogen-chlorine is 428. So for us to understand well, or for the simplicity of the question, I want us to separate our equation here so that we write in a skeletal form. So let's just represent this, or let us write this. So here we have got CC and 2 C's, and there are 6 hydrogen. So this is carbon, and there are 6 hydrogens. That's hydrogen. So, and here we have got chlorine plus, there are 2 chlorine there. So Cl bonded with Cl, forming the product. The product here we have got C, carbon, there are 2 carbons there, C, and then we have got 3, 2, that is 5 hydrogen. So let us count like that. And here we have another hydrogen. And then, sorry, here we have got, I forgot to write here, Cl. Yeah. And here we have got Cl plus HCl. So this hydrogen attached to 1 chlorine. So that is, so for simplicity, we have separated now our equation in this form so that we understand better. So here we have got 6 hydrogen and 2 carbon bond. So the energy bond for carbon hydrogen is 413 kilojoules per mole. So here we have got, there are carbon hydrogen bond, 6 of them. This is carbon hydrogen 1, this is carbon hydrogen 2, carbon hydrogen 3, carbon hydrogen 4, carbon hydrogen 5, carbon hydrogen 6. So there are 6 carbon hydrogen bond. So we multiply 6 of them. So for bond formation, bond breaking, so we have got 6 times 413, that is for carbon hydrogen, which is 413 kilojoules per mole, and there are 6 carbon hydrogen bond there, plus Here we have got carbon-carbon bond. The carbon-carbon bond, the bond energy is 346. So we only have one carbon-carbon bond. So that one is 1 times 346 plus, and then here we have got chlorine, that is one of it. So the bond energy is 240 times 1 times 240. So that will give us, for bond breaking, we add that one. Let's use our calculator. So here we have 6 times 413, 6 times 413 plus 1 times 346 is just 346 plus 346 plus 1 times 240 is 240. So that is 3,064 kilojoules per mole. 3,064 kilojoules per mole. So that is the energy for bond breaking. So let us again add up the energy for bond formation. So bond formation, So here we have got carbon hydrogen, which are 5 of them. So there is 1 carbon hydrogen, another carbon hydrogen, carbon hydrogen, carbon hydrogen, carbon hydrogen. So there are 5 of them. 1, 2, 3, 4, 5. So that is 5 times carbon hydrogen bond is 413. That is carbon hydrogen bond. The energy bond is what? 413 plus, here we have got carbon-carbon bond. Carbon-carbon bond, the energy is 436, and we have only one carbon-carbon bond. So 1 times 346 plus, and then we have got carbon-chlorine bond, and is only one carbon-chlorine bond. So the energy of carbon-chlorine bond is 327. So 1 times 327 plus, and then here we have got hydrogen and chlorine. So we have got one hydrogen-chlorine bond. Hydrogen-chlorine bond is 428. So it is 1 times 428. So we add up that. So that will be 5 times 413 plus 346 plus 327 plus 428. So that is 3,166. So that is 3,166 kilojoules per mole. So the enthalpy change of the reaction is equal to the energy taken in minus the energy taken in minus energy given out. So the energy taken in is 3,064 kilojoules per mole minus the energy taken out, which is 3,166 kilojoules per mole. So let us do that calculation. 64 minus 6166. So that is 102, negative 100 and negative 102 kilojoules per mole. So we can easily now tell whether the reaction is endothermic or exothermic by looking at our answer there. If the answer there is negative or the energy is negative, that means the reaction is exothermic reaction. So the enthalpy change for this equation is negative 102 kilojoules per mole, which is an exothermic reaction. So the reaction is exothermic. So the delta H, you write here, is equal to negative 102 kilojoules per mole. So delta H is always written after the equation and the sign is shown like that. So that is how to calculate enthalpy change